So you were to discuss with a partner, what does the word dilate mean? Anybody want to share? What does dilate mean? Yes.
So, isn't it like sometimes when you're at the eye doctor, they dilate your eyes, which makes some people see bigger?
Good. Anybody else? Dilate. So she's on the right track. Okay. So dilate is enlarging or getting smaller. Okay. So a dilation is a transformation in which a figure is made larger or smaller with respect to a fixed point called the center of dilation. Okay? So it's a transformation. This is one of 4 transformations that we're going to look at. The ratio of the side lengths of the image to the corresponding side lengths of the pre-image is the scale factor of the dilation. Remember, we learned that on Wednesday. Image is the new and pre-image is the original, right? So new to original, right? For dilation, so pre-image and its image are similar. Similar figures. We're still talking about similar figures. Remember in math, the word dilate means to shrink or expand a figure. So this example here of 2 figures, you can see the smaller one getting larger. Or if we started out with the larger one, it's getting smaller. Okay? And this is just this point is just your center of dilation. Okay? Okay, when you dilate the figure, the scale factor is going to be represented by the letter K. Right, so every time you see the letter K, that represents what? You got it. So when you dilate a figure, the scale factor tells you by how much you need to expand or shrink it. Okay? Were we kind of doing that the past few days? Figures are getting larger or smaller. Okay? When your scale factor is greater than 1, your figure expands, it gets bigger. When your scale factor is less than 1, what happens? Scale factors are less than 1. Your figure shrinks. It gets smaller. To dilate a figure on the coordinate plane with respect to the origin, what operation do we do? What do we do when we use scale factor? What have we been doing the past few days? We multiply, absolutely. So to dilate a figure in the coordinate plane, so we're going to be looking at figures on the coordinate plane, okay? We're going to multiply the coordinates of each vertex by the scale factor. And scale factor is represented by K, so either 1/2 or 2.5, okay? This is very important, okay? This is an algebraic rule for dilations, okay? So we have our original set of points here, okay? This is our rule. this is how we apply. What does that mean? Kx. What operation is that? It's multiplication. So we're going to multiply our scale factor by x, multiply your scale factor by your y value, and then you have a new set of points. Okay? And you apply that to all the points to dilate your figure. So let's do that. In example number 1, we're going to dilate a figure with a scale factor greater than 1. What is going to happen to our figure if our scale factor is greater than 1? It's going to expand or it's going to get bigger. All right, so we are going to graph the dilation using a scale factor of 2 and 0, 0 as the center of dilation. Okay, the origin will always be the center of dilation. Okay, we need to first identify and record each point in the pre-image. This is our pre-image. Okay, triangle DST. All right. So what is point T? What are the coordinates? Here's your origin. What is that point? Good. What are the coordinates?
1, 1.
Thank you. Good. Okay. Let's look at point D. What are the coordinates for point D? Good. -1, -1. And point S?
-1.
1, -1. You're going to go positive 1, then down 1. Remember, always X first, then your Y. Okay? Identify the scale factor and predict if it will expand or shrink. What is our scale factor?
2.
It's 2. Okay? So how are we going to complete our rule? If this is our original points here, right? What are we going to replace K with?
2.
You got it. So what are we doing to each value? We're multiplying it by 2. So our new, so T prime, its coordinates are what? You got it. 2, 2. Are we good? D prime is? 2. Got it. -2, -2. S prime is now? Good. So we know that our triangle TDS should what? Enlarge. It should expand. It should get bigger. So now we are going to plot and then connect our new points. And we're going to label. Always label with the prime notation. That's important. Okay. So T prime is 2, 2. Plot your dot and label it. Okay. Let's do that with D prime. We got -2, -2. Plot the point and label it D prime. S prime's coordinates are 2, -2. Plot your point and label it S prime. Now we're going to connect the new points. So when you plot it, is that a good check if we did it correctly, if it's supposed to expand? Absolutely. Okay. Let's move down to example number 2. We're now going to dilate a figure with a scale factor that is less than 1. What should happen to our quadrilateral?
3.
Good. It's going to shrink or get smaller. Absolutely. Okay, so we're going to graph the dilation using a scale factor of 1/2. And again, the origin is always the center of dilation. Okay. Again, let's identify and record each point in the pre-image. So what is our coordinates for N? -1.
4.
You got it. -1, 4. J is what? Here's your origin.
3.
3, 1. Remember, we always do X and then Y. Our rule is always our original. Point M is what? Do we go anywhere?
0.
Good. 0, -3. And then Z is -2, 0. Okay. Identify the scale factor. What's our scale factor? Half. There's a decimal there. It's half. Okay. So what is our rule going to look like? This is our rule. Anytime you have to write the rule, make sure you include the original. And then what are we going to replace K with? Good. 0.5. And you're more than welcome to put it as a fraction as well. Either way. Okay? So now let's apply. When we apply, what operation do we do? We're going to multiply 1/2 to each x and y value. Okay? So n prime is now -0.5, 2. Are we good with that? J prime is now good. And then M prime,
0.
good. And now Z prime,
-1.
0, right? We're good? All right, so now we're going to go ahead and plot and connect the new point. So N prime is now -0.5, so we're going to go halfway. And then up 1, 2, plot your point and label it N prime. You good? Okay. J prime is 1.5. We're going to go up 0.5, right there in the middle. We're going to label it J prime. We can kind of see it already shrinking. That means we're plotting correctly. M prime is 0, -1.5. Plot your point, label it M prime. And Z prime is -1, 0. Plot your point and label it Z prime. Now that we have all 4 plotted, connect them the best you can. So our scale factor of 1/2, did our figure shrink?
Yes.
Woohoo! All right, so now what I want you to do is on a scratch sheet of paper, I want you to set up your paper with letter, word, and answer. So where you begin, you will end.